Hello guys, in today's lesson, you're going to be solving questions on circular motion. In our previous set of lessons, we derived a couple of formulas, on circular motion. We perfected everything on the various formulas on circular motion. We derived basic formulas and also some major advanced formulas. So I love you, if you've not seen this lesson, I would love you to go and see them because if you don't know those formulas, there's no way, you'll be able to keep up with this very lesson today. So right here we have the first question on the board. A wheel 25 centimeter in radius turning at 120 revolution per minute, that's rev per minute, RMP, increases its frequency to 660 rev per minute in 9 seconds, like 9.00 seconds. Find the constant angular acceleration. Now, in our previous lesson, we derived the various formula, but there's something I want us to quickly, look at before we solve this very question. Now, the same way we have various kinds of, formulas for for linear or tangential quantities. That's the same way we have this various formulas also. I can call it equations of motion for angular or for angular or centripetal quantities. Now this is what I mean. When we talk about equations of motion, we have v equal to u plus at. And let me just do it this way. Let me differentiate them. We have for linear or tangential, and this is angular or centripetal. Angular or centripetal. Now, don't forget for circular motion, since you're talking about two-dimensional motion, most of the things we work on circular motion are divided into linear and angular. Now, for the linear, it's very common. Everybody knows this. We know this for linear. V equal to u plus at. We have s equal to v plus u over 2 times time. We have v squared equal to u squared plus 2as. And also we have s equal to ut plus half at squared. All these are linear stuff. These are linear equations of motion. And also we have, I love this formula, s equal to vt minus half at squared. Now, the way we have all this bunch of formulas under the linear or tangential, quantities is the same thing we have under angular or centripetal quantities. So let's see what it's going to look like for angular or centripetal quantities. So for this centripetal quantities, what we have, the final velocity here is going to be angular final velocity equals to angular initial velocity. Just going to be replacing them. Then it's going to be, since this is linear acceleration, this will be angular acceleration times time. Now the same thing that's for the first. Then the second, we have this is a linear speed. This is a linear distance, I beg your pardon. It's going to be angular distance in rev or rad equals to final velocity plus initial velocity over 2, which is average angular, average angular velocity times time. Now the same thing we're going to do here. What do we have here? This velocity raised by 2. This the final velocity squared. Final velocity squared equal to initial velocity squared plus 2 times angular acceleration. I love to use my alpha. We could use acceleration c, centripetal acceleration, times angular distance. And the next one, we have angular distance in rev or rad equals to then angular velocity. That's final angular velocity, initial angular velocity, I beg your pardon, times time. Then plus 1 over 2 times angular acceleration times time raised to power 2. So the very final one is angular displacement times angular distance times final angular velocity times time minus 1 over 2 times angular acceleration times time raised to power 2. Now, if you look at this very formula, they are the same thing. The only difference is this ones here are linear or tangential, while this ones here are angular or centripetal. So you're going to be using the knowledge of this to solve this very first question. Just very easy. All the formulas we've derived, these are not new formulas, but we're just trying to be creative with this, very stuff. So quickly, it's high time we solve this. So what are we going to do first? The first thing we're going to do, let me just quickly take up this. Let me take up this very portion of the linear or tangential. We'll leave the other portion. So let's see what we have. What do we have here? The wheel, 25 centimeter in radius, the radius of the wheel is 25 centimeters. So when we convert this wheel to meters, what are we going to have? 100 centimeter make 1 meter. So 25 centimeter to meter will give us 25 over 100, which will give us 0.25 meter. So we have our radius already, 0.25 meter. Turning at 120 revolution per minute increases its frequency to 660 revolution per minute in 9 seconds. So rev per minute is almost the same thing as rad per second. So when we talk about rev per minute here, we are talking about angular velocity. That's what we're talking about. Don't forget, for angular velocity, it is angular displacement over time taken, which is always in rad per second, often in rad per second. So look for a way to convert this. This is initial angular velocity, which is 120 revolution per minute. We're going to convert it to rad per second. Quickly, you're going to do that. And it increases its frequency to 660 revolution per minute. So final angular velocity is 660 revolution per minute, rev per minute. We're going to convert it to rad per second. It took this whole movement 9 seconds, time, 9 seconds. So what is going to be the constant angular acceleration? So as you can see, we have everything set out. We're looking for angular acceleration. We are looking for this. I think this equation of motion will help us. There's it here. Final angular velocity equal to initial angular velocity plus angular acceleration times time taken. So everything is well set out. We have our time. We have this. So first of all, we're going to look for a way to convert this. 120 revolution per minute will be converted to rad per second. So how do we do that? Now don't forget, one revolution is equals to 360 degrees, which is equals to 2 pi 1 rad, 2 pi rad, that's 2 pi r. We said this already in our previous lesson, we discussed this. So that means one revolution is equal to 2 pi rad. So one revolution is equal to 2 pi 1 rad. So if one revolution is that, then 120 revolutions will be how many rad? X rad, then we cross multiply. So that will be x 120 times 2 pi rad. So that will be 240 rad. So we're done converting that. So we have 240 rad. So now we're going to convert 1 minute. We converted 120 revolution to rad. So we're going to convert 1 minute to seconds. So how many seconds do we have in 1 minute? 60 seconds make 1 minute. So now you're going to convert this. So it means the first angular, the initial angular speed will be 240 rad, 240 pi rad, I beg your pardon, 240 pi rad over 60 seconds. This is what we have. 240 pi rad over 60 seconds. That's what we have. So we divide. So what do we have? We have 4 pi rad per second. That's what we have here. So yes, 4 pi rad per second. That's what we have. So we're going to do the same thing for this, for the final. So the final speed will be 660 also. 660 will be just like what we have here, 660 times 2 pi rad divided by 60. 0 takes us 0, 6 here 1, 6 here 11. We have 22 pi rad per second. So we have everything set out here. We've converted our initial, our initial angular velocity to rad per second, and our final also to rad per second. So it's high time we solved for the acceleration. It's high time we solved for. So let's take off this portion where we did the conversion, and let's quickly solve it. So what do we have now? We're going to use this equation of motion. So angular final velocity is equals to angular initial velocity plus angular acceleration, that's centripetal acceleration times time. So we're going to fix in our values. We're going to put in all those values into what we have here. So what's the final velocity? We have it right here. 22 pi, that's 22 pi rad per second equals to what we have right here, 4 pi rad per second. Then plus what we are looking for, angular acceleration times time. What's the time? The time is, what time? 9 seconds. The time is 9 seconds. So we're going to collect our like time to send this over. 22 pi rad per second minus 4 pi rad per second equals to 9 alpha. So 22 pi rad per second minus 4 pi rad per second is 18 pi rad per second equals to 9 times angular acceleration. Divide both sides by 9. Don't forget that is 9 seconds. There's 9 seconds right here. So what do we have? This takes out this. So 9 here 1, 9 here 2. So what do we have? The angular acceleration is equals to 2 pi rad per second squared. So that is that for the angular acceleration, as simple as ABC. So that's all for this very lesson. If you found this very lesson helpful, please subscribe to this very channel at EduMosaic and follow me also on Facebook at Revelation of Even as we draw the curtain on today's lesson. See you in the next lesson. Thanks.